So let us prove the reduction formula for gamma n. Okay, gamma n. Okay, let us prove gamma n plus 1 brackets is equal to n gamma n. Okay, now by definition we have gamma n plus 1 is equal to an integral 0 to infinity e to the power of minus x to the power of n dx. Okay. Now integrating by parts, we have that is minus x to the power of n e to the power of minus x 0 to infinity plus integral 0 to infinity n x to the power of n minus 1 e to the power of minus x dx. Okay, now let us take this as equation 1. Now the limit as x tends to infinity, x to the power of n e to the power of minus x is, that is x to the x to infinity x to the power of n by e to the power of x, which is equal to 0. Okay, by successive use of L'Hopital rule. Okay. Also, limit as x tends to infinity x to the power of n e to the power of x is now this will be a limit x to the power of 0 x to the power of n by e to the power of x is 1 plus x square by 2 factorial and so on, which is also 0, right? Hence minus x to the power of n e to the power of minus x 0 to infinity is 0. Okay. The equation 1 becomes gamma n plus 1 is equal to n 0 to infinity x to the power of n minus 1 e to the power of minus x dx. Okay, therefore gamma n plus 1 is n gamma n. Okay, now let us discuss the cases when n is positive, n is a positive integer, n is positive fraction, n is negative fraction. Okay, let us see this. Okay, gamma n plus 1 is equal to n gamma n, where n is positive integer, n is positive fraction, and n is a negative fraction. Now n is a positive integer. Okay, so if n is positive integer, then the repeated application of the reduction formula we get, that is gamma n plus 1 is n gamma n, which is equal to n minus 1 gamma n minus 1 again n minus 1, this would be n minus 2 gamma n minus 2, right? And So it'll be n into n minus 1, n minus 2, n minus 3, 3 into 2 into 1, gamma 1. Okay. So, but gamma 1 is equal to 1. Okay. Hence, gamma n plus 1 is equal to n factorial. So, if n is positive integer. Okay. So, n is a positive fraction. When n is uh, a, a positive fraction, then gamma n is equal to n minus 1 comma comma n minus 1, right, which is equal to n minus 1, n minus 2, gamma n minus 2, and so on. So this process is to be continued as long as the factors remain positive. Okay, for example, if you have n as 13 by 4, okay, gamma n, okay, as gamma 13 by 4, which is n minus 1, 13 by 4 minus 1, gamma 13 by 4 minus 1, which is equal to 9 by 4, comma 9 by 4. Okay, and further 9 by 4 multiplied 5 by 4, gamma 5 by 4, n minus 1. Okay, again 9 by 4 multiplied 5 by 4 multiplied 1 by 4, gamma 1 by 4. So the value of gamma 1 by 4 can be reduced from the gamma function table. Okay. Now n is a negative fraction. Okay, let us consider the case when n is negative fraction. So gamma n plus 1 is n gamma n. Okay, so gamma n is gamma n plus 1 by n, where n is not equal to 0. So by 1, okay, uh, that is 1 by n gamma n plus 2 by n plus 1. Okay, here n is not equal to 0 and minus 1, right? 1 by n into n plus 1. Now for this, gamma n plus 2 becomes gamma n plus 3 by n plus 2, right? Now this is not equal to 0, minus 1 and minus 2, right? And this further would move on to gamma n plus k, right? Let us put k plus 1, right? Divided by n into n plus 1, n plus 2, n plus k. Okay. Now let us keep this equation 2. This is gamma n. Yeah. Further, now n for that is for n not equal to 0, -1, -2, and minus k. Yeah. Now, which defines n is a negative fraction, k being the least positive integer, for which n plus k plus 1 k plus 1, which is greater than 0, right? Uh, so hence we have obtained this. Thank you for watching.